A rocket is launched vertically, so it's coming up here like this, and as it does so, the angle of sight to it changes until at this point right here, the angle of sight to it is theta. So here's the rocket up here. All right, it's the station is located 6 miles from the launch pad. And theta is the angle of the line of sight to the rocket, which is increasing 5 degrees per second when the angle is 60 degrees. So we're taking a snapshot where here is the moment where the angle is 60 degrees. What is the velocity of the rocket at this instant? And it's going to be in some kind of miles per second. Okay, so come over to here and we say theta is a function of time, so it's theta of t. Because as time goes on, the angle of sight to the rocket gets larger, so it's changing with time. H is also a function of time. The height of the rocket is a function of time because the height of the rocket is a function of the angle. So the bigger this angle is, the higher the rocket was. And theta itself is a function of time. So we have a chain rule situation here. So then we set up the relationship. The tangent of theta is the opposite over the adjacent. So h over 6, which then means that we have h equals 6 tangent theta. So we differentiate with respect to time. And this is where you need a dt notation, because you want to know what's in the denominator. What are you differentiating with respect to? So here we're doing it with time. So it's 6 times the derivative of tangent is 1 over cosine times the derivative of the inside. The inside is the theta function with respect to time. So that's the chain rule in action. We are given that the derivative of the angle with respect to time, in other words, the rate of change of the angle with respect to time when we're at 60 degrees, is 5 degrees per second. Now we have to change the degrees into radians, and that is because the units don't all cancel out and work out to miles per second if you have a degree unit in there. Radian measure is unitless. There are no units to a radian, so it's like transparent. So we have 5 degrees, and a degree is pi over 180 radians, because there's 180 degrees in pi radians, the same coterminal angle. So you multiply that, and that changes it. The degrees from the 5 and the 180 cancel out, and you get pi, the radians here, so you end up with pi over 36 radians per second. That's critical. You have to do that. The 60 degrees we can leave as a degree because it's going to be evaluated as a trig function. We could convert that to radians also, but there's no harm in leaving it in here. So at 60 degrees, dh dt, the rate of change of the height with respect to time, is 6 divided by cosine squared 60 degrees times the pi over 36 radians per second. Then the cosine of 60 degrees is the 1/2, and again that's because if you have your unit circle and you're 60 degrees is the tall angle, your x is going to be 1/2 right there. So it's 1/2 squared. So you do the algebra on that, and it comes out 2π/3 miles per second. And just for your information, if you wanted to know what miles per hour that was, a second would be 1/3600 hours. Do the algebra on that, it comes out 7,539.8 miles per hour.